Hi folks, today we're going to talk about piecewise functions. We're going to practice with a graph a couple different times, but at first I just want you to understand what a piecewise function is. A piecewise function is a function that is pieced together. So it comes from several different functions that are kind of connected. And so what we're going to do today is we're going to write out the equations for each of the pieces, and then we're going to define them by what interval they're happening in. And so at first I'd like to just kind of split this up so that you can see exactly what we're talking about when we talk about pieces. So in this function that you see on the board, the first piece starts right here, right? So it's going through what looks like an x value of -9. And this piece travels in a nice positively sloped line, but then it changes right here and it starts doing something a little different. And so this is kind of the interval boundaries for that first piece. Now, if we continue on, this graph is sloped positively just in a different way, here, 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 and then it starts doing something else different here. And so this is going to be another boundary of our piecewise function. We've got a new piece that has a negative slope in their line. It stops being negatively sloped right here, so that's a boundary for our interval. The graph then begins to increase ever so slightly, and it stops doing that right here, so there's another boundary for the interval. And then finally, the graph continues on and on until infinity, and that's the last interval. And so you'll notice that the graph has 1, 2, 3, 4, 5 different intervals. It just so happens that underneath you have 5 lines for those 5 pieces of the graph. So I'm going to slide this up so that we can kind of see what is expected of us. The bottom part says, write the piecewise function in point-slope form. It provides that for you. It also says, remember, solve for y so that y equals or f of x equals is at the beginning. We have f of x equals at the beginning already. And so what we need is the rest of the equation on the other side of the equal sign. If you look at your piecewise function point-slope form, that tells me that this is going to stay, but this has to go to the other side. So think for a moment, how do you move a negative y1? Well, of course, if you're moving to the other side, you would add y1. So we should have y1 tacked on to the end of our point-slope form. It says also for the restricted domain, so that's what this area is going to be for. Domain. We're going to use inequality notation. So we're going to describe the intervals in inequality notation. So let's go look at the first one at the top. The first function is this function right here, and it starts out at -9, and it goes all the way until an x value of what? -1, -2, -3. So that tells me that the interval is going to be from -9 to -3. So I'm going to go ahead and put that interval right here in inequality form. X is between -9 and -3. You'll remember that an open point at -9 means we use the less than sign, and then we're not going to include the -3 in this domain, this interval, so we're just going to use the less than sign here as well. Now, we do need the equation for this. So we need to calculate the slope. We need to calculate a point that's on that part of the line. So how do you find slope from a graph? Well, you can do rise over run. So if I go from this point to the next nice pretty point, perhaps even all the way to the end here so that I know I'm taking care of my slope of the entire line, I can go up 1, 2, 3. That's my rise. And then my run is 1, 2, 3, 4, 5, 6. That simplifies to 1/2. So that'll be the slope that I use. I can also use any point that shows up on that line, and it's typically a good idea to use an endpoint because those will usually be nice and neat. So I'm going to use this point right here. That's the point -3, 0. So a slope of 1/2 and a point of -3, 0. So in my piecewise function, I'm going to follow my formula. I have f of x equals, I'm going to start out with my slope, so 1/2. I'm going to open my parenthesis. I'm going to put x minus x1, so x minus, should be minus -3, but we know subtracting a negative means really plus 3. And then I should have plus y1. So I'm adding that y1 value over to that side, plus 0. And there's the first piece of my piecewise function. I have the equation of the line, and I also have the interval, the x's, for which that equation is happening. So let's go try another one, and then we'll pause the video and let you try a few more on your own. So the next one, let me switch colors for this. There we go. The next piece starts from an x value of -3, and it travels until this boundary, which has an x value of 0. So we're going to go from -3 to 0 for our interval. Now, we talked about not including the connective point, but the function is defined at an x value of -3. So since you didn't include it here, you must include it here. We won't include the 0, we'll include the 0 in the next interval. So let's go find the equation. We need the slope and we need a point. So in this second interval, if I find the slope, the rise is 1, 2, 3, 4, 5. The run is 1, 2, 3. So that's 5/3. That's my m value. And then I'm going to use a point. I can use the same point again because it's on this line as well. I could also use this point. So maybe I'm going to use -3, 0 again. So I have f of x equals. I need to write my slope, which was 5/3. And then I'm using the same point. I'm using the same x1 and y1 that I used previously. So I can sort of copy down what I had. Oops, 0. Sorry about that, 0. I can copy down what I had previously because I used the same point. So I'm going to ask you to pause the video and try the next two. Try the next two. So pause the video, try the next two. All right, folks, so check to see what you got for the next two. Some common mistakes that may be made is the slope. Whenever you're counting rise over run for the slope, perhaps you didn't count all the way from one endpoint to the other. So down 5 and right 5 means -5/5. That means the slope is -1. For the next piece, if you rise 2, you have to run 7, and that slope is 2/7. It definitely looks like if you rise 1 and you run 3, you end up back on that line. But if you do it again, you don't quite get back on the line, so you know that slope is incorrect. Also, a mistake that may occur is remembering that if you have 0 here with a less than sign, then you're going to pick up at 0 again, but you've now got to include that 0 in the next interval. So you'll notice that we've got this pattern of less than or equal to, less than or equal to, less than or equal to, and less than, less than, less than. So that happens frequently. So in the last portion of the graph, the last piece, it starts out here at, positive 12. Positive 12. It's just a flat line. It's constant. So if I went from this point to this point, the rise is 0, the run is 2. So a slope of 0 over anything is still 0. That's a 0 slope. If I pick a point that's being used, perhaps I pick this point. That point is 12, 2. So in point slope form, I have 0 for the slope. I have x minus my x value, which was 12. And then I'm adding to it the y1 value, which was 2. Now this part of the graph we said started at 12. So we're going to include 12 in our interval. And it goes on until infinity, so we don't put anything remaining here. It's just that 12 is less than or equal to x, and we've finished. So I'm going to switch to the next problem. The next problem is identical with piecewise functions, with respect to piecewise functions. So you have the same graph, but this time the instructions are a little different. It says, use the given graph, again, the same one from the first graph, and write the piecewise function in slope-intercept form. So that looks a little different, y equals mx plus b. And in addition to that difference, it also says, for restricted domains, use function notation form. So what we're talking about is parentheses and brackets, and this is essentially interval notation. So what we need to remember from the previous notes is how to transform from point-slope form to slope-intercept form. And we'll be doing that for each piece of our graph. So let's practice on one of our problems. In fact, let's go ahead and practice on this one. So in order to make this look like slope-intercept form, first I need to remove the parentheses, and I do that by distribution. So 1/2 times x is 1/2 x, and 1/2 times 3 is 3 over 2. If I add 0 to it, there's really nothing to do there, so I can kind of get rid of that plus 0, and now all of a sudden I have it in the form y equals mx plus b. Keep in mind that the interval doesn't change because the graph is exactly the same. So I can go write 1/2 x plus 3/2 on the line for my first piece of the piecewise function. We said 1/2 x plus 3/2. Remember also that we want to transform our notation from inequality to interval notation. So previously on this problem, our notation was -9 is less than x, which is less than -3. Those were our boundaries, -9 and -3. So they're going to be our boundaries in our interval notation as well. There was an open point at -9, so we use a parenthesis. And we did not include -3, we included it in the next one. So I'm going to put a parenthesis here as well, but perhaps I open this next one up with a bracket, remembering that the next piece will start at -3 and include that point. So let's try one more, and then I'm going to let you try some on your own. We'll do the blue one next. For the blue one, if I distribute the 5/3, I end up with 5/3 x plus, I've got 5 times 3, which is 15, and 15 divided by 3 is 5. I also have this plus 0 at the end, and I'm sorry, I'm using different blues. If you notice that and it bothers you, I'm so sorry. It would bother me too. So if I add these two together, I still end up getting plus 5, right? 5/3 x plus 5. So let's go ahead and tack that in to our piecewise function. Five thirds x plus 5. And it was from the interval -3 to 0. So I'm going to go from -3 to 0, close my parenthesis, open up the next one with a bracket. So pause your video and try the remaining 3 functions. So check your work, remembering that in the interval notation, we end with a parenthesis, we start with a bracket so that the point is included at the beginning. I do want to talk about briefly this one down here simply because the last piece is a constant equation, a constant function. And so if I were to extend this back, it would cross a y value of 2. So in that equation, we'd have y equals 0x plus 2. And that 0x does not need to appear. So horizontal lines look like that. So this is part 1 of your notes. Part 2 will be very brief, and if you will click on part 2 now and finish your video, I'll see you later. Bye, guys.